So welcome everyone. My name is Mia Michalczyk. I'm a postdoctoral fellow with the International Water Management Institute IWMI, based in Accra, Ghana. And I'm going to present some work I did with Wageningen University on the resilience of smallholder farms and farmers in northern Ghana. So in this presentation, I'm going to give some context on previous work we've done on farm and farmer typologies, analyzing farm performance, performance with technology packages, the room to maneuver of farms, and we're going to build on that to explore their resilience. We're going to look at concepts and methods, shock scenarios, their vulnerability, and their buffer and adaptive capacity as a basis for some conclusions and discussion. So the context of this work is farming systems research with a focus on sustainable intensification. I've been working for Africa Rising in Ghana. That is a project from the USAID Feed the Future program. And this is now continued by the Sustainable Intensification of Mixed Farming Systems, CGIAR initiative. And under Africa Rising, there were so-called technology packages. So a bundle of technologies and techniques that were defined together with farmers and trialed in so-called technology parks. One of the technology parks was located in the northern region in Duku, in a community that I'm highlighting here. So when I came in with my PhD work, the question was what works for whom and how. And if we ask what works for whom, we're talking about the diversity of farms and farmers. And so we worked with typologies. And we also, per farm type, used the whole farm model farm design to model resource flows and to determine the performance. And then we build in those technology packages in the model in an ex-ante impact assessment. That means we have implemented in the model something that didn't happen yet fully in reality. So we were foreseeing what could be the effects. And we used all of that knowledge now to also explore the resilience to certain shock events of these same farm systems. So in our research, we looked, first of all, at household level survey data. And you see that on top, that's the statistical typology. We used principal component and cluster analysis, and we can see that there were some farm types determined. There are low, medium, and high resource endowed households with some structural features like animal composition, numbers, but also some functional features like off-farm activities, market orientation, hired labor, and so on. But we also had this lead author, Katja Kuivainen, who had an anthropological background, and she engaged really closely with the community and asked them how they view diversity in terms of farmers and farms in the community, and they described household members rather than households. They said that there are big farmers, individual farmers, men who have a market orientation, maybe there's medium farmers and variable orientation, small farmers, men who have a subsistence orientation, women and children who don't own land. So that was very interesting for us, and we picked up the basic principle of these insights to say that actually there's a horizontal diversity of households, but also a within household vertical diversity that is a repeating pattern of resource endowments and roles and interests within the household. And just to give an example again for Duku, where one of the technology parks was located, for a low, medium, and high resource endowed household, you can already see how much more assets and how different the different farm types look like, and the amount of and composition of household members and crops grown. And we used that, and these particular farm systems have been modeled and explored for their performance and for their performance also under the technology packages. So we explored the resource flows and performance for a low, medium, and high resource endowed farm household at 3 sites: in Duku in the northern region, in Nyango Upper East, and in Zanko Upper West. And these are the type of results that we got. I'm going to go more in detail. We got this, for example, the performance of the farms. Then you have the technology packages, an analysis of how the different low, medium, and high resource endowed households perform under the different packages, and then we explored their room to maneuver. Let's go into more detail. Here we see the current performance, so that at that point in time we took kind of a snapshot of the farm systems. We put their system into farm design, and we could explore how the low, medium, and high resource endowed households in the different regions. So NR is for northern region, UER in orange is upper east region, and in dark orange upper west region, UWR. We can already see those if we look at profit. The bar charts really showing how much more profit per year a high resource endowed farm gets. But we can also see at the same time that per hectare or per person, the profit is not so much higher, a little bit higher, but not so much higher. And we also have to remember when we say income or profit per person that we don't know anything really about the income distribution, the real income distribution, power over income within the household. Also, we see that a bit with labor and with soil organic matter. These are just to give an idea. If you want to see the details, you can look at the paper model results versus farmer realities in agricultural system. So now that we had described the current farm performance at that point in time, we wanted to know how would the different farm systems perform with the different technology packages as far as these were applicable. So let's have a look at the technology packages. So just I'm increasing the size here because it's not very well readable. So there was a technology package on maize. This is P1. And here we talk about improved seeds, row planting, and double the traditional amounts of sulfate of ammonia. Again, you can see things like improved seed and fertilizer amounts. These are more technical things, while row planting is more of a behavioral, so a technique aspect of the bundle or technology package. The second package is on cowpea. It's a particular variety, row planting and sprays with lambda. And the third package would be integrated soil fertility management on soybean, including inoculum and triple superphosphate, maize legume rotation, and a maize legume strip cropping. Again, you could go into this paper to go into all the detail, but these were the defined technology packages that we implemented on the different farms to see the impact. So when I say they were implemented on the different farms, I mean we modeled their performance in an ex-ante fashion. Here again, the technology packages, and we can see the low, medium, and high resource endowed farm. And we can already see there are many bars at the low resource endowed household, right? So that means there's a high relative change in response to these packages. We also have to consider these black dots, which indicate the total area that has been assigned to that technology package. For example, at low resource endowed, we see it's actually 100% of the area has been put under package 1. That's because the low resource endowed only had one maize field. So we converted in the model all of that household's maize field to P1, and that had a relatively large impact. While for the medium resource endowed and the high resource endowed, we see the percentage is much lower of the area. That's also because they have many different crops. We didn't replace other crops, we replaced their maize fields. So then the relative importance of that package in comparison to the total area and the total income that farm generates is lower than for the low resource endowed household. We also see a high green bar chart for the low resource endowed. Green represents soil organic matter balance, and that is because each of these packages include the incorporation of green manure, meaning the residues of the crops on the fields. We assume that it would be plowed back into the soil instead of burnt, because burning was the common farm practice. And for the low resource endowed household, the model determined that this would make a large difference. That was also because the low resource endowed household had no livestock. So these crop-related fertility measures really had a disproportionately high positive impact. So you can also use the whole farm model farm design to explore so-called alternative farm configurations. So you give the model a room, you say, okay, you can increase or decrease all the crop areas or the different animal types and change management practices and so on. And then you run it at certain iterations, and then model gives you these kind of graphs. Each dot in the graph here represents an alternative farm configuration, and I've labeled the solution clouds with the respective farm types. So you see the HRE, high resource endowed household, has a very large yellow solution cloud. The yellow is for Duku, for the northern region, while the low resource endowed has much smaller solution cloud. It means it has less options to change its farm configuration. That also makes sense. We saw in the beginning how different the farm types were in terms of their resources that they could shuffle. So there's simply more room to shuffle and to improve their operating profit, decrease their labor balance, increase their soil organic matter balance. So that's what you see on the X and the Y axis. And yeah, you can visualize how much more space the higher resource endowed households have to maneuver. So now that we've looked at the basics of farm systems, the technology packages, their performance, their room to maneuver, let's shift our focus to the resilience and challenges that farmers face. So our focus was Northern Ghana, and I have actually presented this in a course of students that have worked with farm communities, and they gave me, through Mentimeter, some insights on what they felt were the main challenges for smallholder farmers, like erratic rainfall, soil fertility, drought, access to land, high input prices, lack of capital. So these were their thoughts. So when I asked farmers about their challenges, the first thing they mention is money. But then, of course, money for what is the question? And they might answer money for taking care of our health, to buy inputs, to take care of crop, livestock, pests and diseases, to address the lack of knowledge. That's a challenge too, the labor constraint, and there's out-migration, again reinforcing the labor constraint. There might be drought and floods, market price fluctuations, soil health. So these are challenges, but when we focus and zoom into shocks, these are then of course events that are sudden and big. It could be a health shock, it could be a drought, a flood, a market price fluctuation. So we're going to look further into that. So in order to explore resilience, we needed to ask some fundamental questions. And what you see here is our conceptual framework for a paper that we've published in the International Journal of Agricultural Sustainability. The title is Preparing for, Coping with and Bouncing Back After Shock, a nuanced resilience assessment for smallholder farms and farmers in Northern Ghana. So let's focus on these questions. We ask resilience of what? So what systems are we looking at that should be affected or should be resilient rather? And these are farms and farmer types that we've already explored. Okay, resilience to what? Then we talk about severe shocks. And I'm going to talk in a minute about how these were selected. So we look at price shock, drought, fall armyworm, and a labor shock. And so that means the systems that we are considering are vulnerable to severe shocks. But vulnerable in terms of what? In terms of their farm performance. So that is resilience for what? So for what are the systems operating at all? People want to generate profit and food and maintain their soil health, and it has important social functions. But so while they are vulnerable and they are shocked, they also have a capacity to recover, which depends on their capacities and attributes. They have resources and options to deal with the shocks. So that is in detail resilience through what? And we have already kind of covered with our previous research the farm and farmer types, and also we've looked at farm performance. So what we need to zoom into are the severe shocks and the resources and options. So the shock scenarios, how have we defined them? We looked into literature, and we looked at literature, of course, from the context of Africa and Ghana and Northern Ghana. So, for example, Baru et al. 2020 looks at fall armyworm infestations. Friesen, Yaravura, Tambo and Wünsche are looking at climate shock. So Friesen looks at rainfall patterns, Yaravura at perception of drought, and Tambo and Wünsche looks at climate change related risks. Mewes looked at risk perception among smallholder farmers, and Bangwa looks at health shocks among 4 African countries, and Ghana was one of them. So we sourced some first ideas from there. We also looked at a big data set from the Africa Rising survey, and we did expert consultations. 4 of the 5 experts were from the research for development space, and 1 was an extension officer with ample experience. So this was our kind of background in order to move towards the real expert consultations, which are the farmers themselves. So we asked in Duko, 22 individual farmers, like what they felt were the shocks that most severely affect them and also had a high likelihood of occurring. And this is our list. They said severe drought, severe fall armyworm infestation, severe price reduction, severe labor shock. These are the top 4. And together with them, we define what does it mean, a severe drought? How can we define that? So a severe drought would be defined as 4 weeks of no rainfall in June and July, when the crops are very vulnerable, are just in a very critical growth stage. Severe fall armyworm infestation would happen when there's no preventative action taken. 50% of the total plant population would be heavily infested, resulting into maize yield loss of about 60%. Now, about the severe price reduction, they said if market prices drop by 50% for maize and 20% for rice, millet, yam, and cassava, this was a scenario that they considered likely and had happened before, and that really affected them. And severe labor shock, 50% of the total household labor is unavailable during the peak season, for example, harvesting, due to illness, death, or sudden out-migration. So these were the shock scenarios that we defined together with the farmers and that we modeled in farm design. So here's some basic resilience concepts. We define vulnerability as setbacks in the farm's functions and performance, and buffer capacity as the ability for a farm to recover these functions and performance using current farm components, while adaptive capacity includes the use of additional components such as the technology packages. We've already looked at 5 technology packages from the analysis before, and we're adding 2 more because at the point in time I was doing this resilience analysis, we had more data available to build in 2 additional technology packages. So now when we look back at the conceptual framework, we have this part of through what, capacities and attributes. So let's have a look at what these are. Capacities are robustness, adaptability, and transformability. So a system would be robust if it can withstand a shock so that its functions are not affected in the first place. But adaptability would mean that the farm or farm household assumes management changes, while transformability makes larger changes, more fundamental structural changes. Now, attributes, we can refer to the features of low, medium, and high resource endowed houses. We've seen they have different functional and structural components and different options like technology packages. So these are all of these resources and the space that they can use to respond to a shock. And for the resilience analysis, we added, as I said, 2 technology packages, which is a groundnut package, an improved variety, row planting and spacing recommendation, and a livestock package, including vaccination, deworming, and concentrate feed for small ruminants. And before modeling the farm performance under these shocks, we also asked the different representatives of low, medium, and high resource endowed households how they would evaluate the shock scenarios, the drought, fall armyworm, price shock, labor shock, in terms of effect on their profit and in terms of food security, just to get a general idea how they felt affected. And we can already see that the drought shock really across all farms had really the largest impact. We can also on top of that see that the price shock for the low resource endowed and the fall armyworm is quite extreme on the profit, and the labor shock for food security. And we can also see that the labor shock is also really severe on profit and food security for the medium resource endowed household, while the price shock doesn't seem to affect the high resource endowed farm household at all. Let's shift to the model impacts and farm design. So we implemented these shocks on the current farm performance that we have shown earlier. And we can see that indeed the blue bar is the drought shock. It really affects the profitability of the low, medium, and high resource endowed farmers really negatively. We also see that a gray lower bar on the profitability for the price shock that really affects the low resource endowed household quite severely. And also the labor shock on the profitability for the medium resource endowed. So there's really quite some overlap with what the farmers were saying before. This graphic has a lot of information. I would like you to focus first on the drought shock to go step by step. We have the first bigger column is the profit, then we have labor and soil organic matter, and we see the results, the modeled results per farm type. We see the red bars to the negative, that's the shocked state in terms of profit. You see really the profit decreased, and then we see the green bar just beside it is the buffer. So what we've done, we used the shocked farm performance to run an exploration, and with the green bar, we only provided the model with the current farm components to shuffle around. And with the blue bar, which is the third bar in each respective column, we also gave it the technology packages. And we can see that with the technology packages, especially for medium and high resource endowed, it made quite an impact, for example, for the drought shock in terms of profit. In terms of labor, we also see that the adaptive capacity for the low resource endowed household is quite good. And we really see a large positive bar, again, for the low resource endowed household under adaptive capacity for the soil organic matter. We see that for drought shock, we see that for foul infestation, we see that for the price shock and the labor shock. So that's again linking back to what we've seen earlier, that there's really a high impact on the low resource endowed household through these technology packages. So we see there is an incremental improvement through these additional technology packages for the different shocks. So it makes the different farm households potentially more resilient if they would adopt those solutions in the space. Let's have a look at the solution space after the shocked performance. So these are the solution spaces that the previous graphic was building on. Let's go step by step because it looks complicated, more complicated than it is. Let's look at the left-hand side, low resource endowed farm under a drought shock. We can see the shocked farm performance with this red square. So we see the operating profit is quite low, but they also save quite some labor because under drought shock, they won't invest further. And then we run the exploration, and the blue part, the buffer capacity, is without the technology packages. So the model has determined these solutions, all these blue dots. And what are these solutions? We can see that on the lower bar graph. You can see the a bit yellow and green graph where we can see what the model picked in the beginning and the lower range of operating profit. It had some fallow, but then it decreases the fallow going into maize. There's no package 1 maize because that's the buffer capacity, and the orange part is the remaining area, so that is left fallow, for example. Now, when we are shifting to the green solution cloud, which is with technology packages, the adaptive capacity, we see that the model much quicker or in a different fashion picks the package 1 maize, and that shifts up the game and increases the operating profit a bit quicker. And the same you can see now for medium and high resource endowed households under drought shock. So you can go more in detail in the paper, but I just wanted to show you what we've done in terms of the solution clouds and exploration and farm design. So in addition to modeling the performance under shock and then exploring what are the capacities to recover, we asked farmers, what do you do to recover from a shock? What other options do you have? And we found these gendered strategies. Men were mentioning livestock sales as a very important strategy, almost like an insurance, which was, however, very expensive because there's high mortality rates and also theft. And women mentioned things like producing dawa dawa. These are the black balls that you see there on top. This is made from a carob tree. And this is a food that they can use for home consumption and for sales. And on the lower left, you see shea butter, which is really an important source of income for women, especially in the hunger season when there's not much income from anything else. That's where the shea trees are yielding, and women collect that. They can sell the shea nuts directly or process it into shea butter. And on the lower left, you see a woman processing rice. They usually buy rice, paraboil it, dry it, and then resell it for a better price. So these are coping strategies that individuals within the farm households adopted to provide income, to get back their profits, also partly off-farm profits, so they could reinvest in the next season. From our analysis, in most simple terms, we can conclude that it's household resource endowment, gender, and social network that translate into farms and farmers' different vulnerabilities, but also coping strategies to shocks. They really have a really large array of strategies and capacities and attributes that we can look into, and a greater awareness on farm and farmer diversity in terms of livelihoods, challenges, and coping strategy really enables us better as research for development agents to improve our support to farmers to build more productive, sustainable, and resilient farm systems and livelihoods. And I'm curious, you can contact me anytime with questions on the study, and I would also like to hear your observations from the field. So thank you very much for your attention. As I said, you can contact me anytime. Here are my contact details. You can send me an email. You can add me on LinkedIn. I'll be happy to discuss with you. Thank you very much.